All right, so for the multiple choice, part one, number one, it says a positive point charge Q is fixed on a very large horizontal frictionless tabletop. A second positive point charge Q is released from rest near the stationary charge and is free to move. Which statement best describes the motion of Q after its release? So the first thing is to draw a picture. And so here's our charge Q that's fixed on the frictionless surface. And then we have a charge here, Q, that's released from rest, and so its initial velocity is 0. And so there's a couple ways we can figure out what's going on here. But first of all, let's talk about, we know that force is equal to mass times acceleration. And we know that the electric force is also equal to K times Q, the magnitude of Q times the magnitude of little q divided by r squared. So we'll keep that in mind. Now we also know, since they're both the same charge, that they're going to repel. And so the force for this one is going in that direction. Force. The force of Q on little q is in that direction. Well, if the force is in that direction, we know that it's going to accelerate in that direction. And we also know that its velocity is going to be in that same direction. From here, you can already, if you guys remember from last semester, if acceleration and velocity are in the same direction, this means that speed is increasing. So that'll help you with the selections. But let's kind of go over why some of these are wrong. So for A, it says its speed will be greatest just after it's released. Well, we know that that's not true, because we know that the initial velocity here is 0. And as it moves away from this charge, as it moves this way, it's going to keep increasing in value. The velocity is going to keep increasing because the force is pushing it that way. B, its acceleration is 0 just after its release. No, we know that's not true, because once it's released here, there's going to be a force that pushes it that way, which will give it an initial acceleration. For C, as it moves farther and farther from Q, its acceleration will keep increasing. So we know that's not true, because remember, force is equal to this right here. The electric force is equal to KQ1Q over r squared. So remember, as it keeps moving further away, so as it keeps moving this way, the distance keeps getting larger. Therefore, if the distance keeps getting larger, the force is decreasing. If the force is decreasing, then acceleration is also decreasing, not increasing, because we know that these are equal. And then for D, it says, as it moves farther and farther from Q, its speed will decrease. So for that one, also not true. So if we think about it, yes, we said the acceleration, as it moves farther and farther, it's decreasing. And so, for example, acceleration, let's say the acceleration was 10 meters per second per second. Well, acceleration is decreasing, so it's 8 meters per second squared. Well, remember that acceleration is how our velocity is changing over time. Notice, so it's essentially, acceleration is the slope of velocity. And so if we graphed this, so even though acceleration is decreasing, notice that each of these numbers are still positive. Therefore, our velocity graph, if we graphed it velocity versus time, our velocity, our slope is increasing. Therefore, our speed is increasing, right? Even though acceleration is going down, it's still a positive value, so our velocity is increasing. So that doesn't make any sense for d, so the speed is not going to decrease. So now, the only logical answer, I think, is E. So as it moves farther and farther away from Q, its speed will keep increasing. So yeah, I would go with that one. Another way we can look at this is using the formula, the work of the system is equal to force times distance. We know that the force is moving it that way. It's also the displacement is in the same direction. Therefore, our work will be positive. And if our work is positive, we know that work is equal to the change in kinetic energy. And so here, kinetic energy is equal to 1/2 mv squared minus initial, which in this case, remember, initial was 0, so this is just going to be 0. And here, because our work is positive, this must come out to be a positive number. Or will come out to be a positive number. Oh, it always will, actually, because it's squared. Never mind about that. Anyways, yeah, so here our kinetic energy is increasing, therefore our speed is increasing. That's essentially what you should be concerned about. The kinetic energy is increasing, therefore our speed is increasing. Cool. Hope that helps.